Hey Chris, I heard we're doing something cool tomorrow.
Oh yeah. Tomorrow we're going to finally cut the CNC Router buck for the new RS.
This video covers a lot of information, therefore it is broken into multiple chapters. Move your cursor over the timeline at the bottom of the screen to skip ahead to what interests you.
All right, today's the big day. We're heading up to the NDSU Innovation Studio, and we are going to turn this 22 sheets of plywood into the new buck for the RS.
The reason for creating a new RS buck was twofold. The original buck was built over my 83.5-inch wheelbase frame. With the new frame being 92.25 inches, we would need to rescale the entire shape. If you look at the evolution of the RS builds, the shape has become more refined. I also wanted to catch these refinements with the new design. I decided to once again try using modern technology to create the new RS buck. To start the process, I had the RS 010 buck scanned to get a general guide for the surfacing. Once we had the scans pretty close, I turned to Mr. Rohit Iyer. Rohit had just received his master's in automotive design from IAAD Torino, Italy. Now living in Germany, he was ready to apply his skills. Over a 2-year period, Rohit and I worked tirelessly to refine the RS, fitting it over my chassis and all the moving parts of the car. There wasn't a single element of the design that was overlooked. Working with someone on the other side of the globe can be difficult, but we persevered and now we have the files ready to cut. Today we will meet with Dave Savageau, who heads up the newly opened Innovation Studio at NDSU. Dave is also a master fabricator, welder, and well-versed in CAD. The RS will be the first project cut on their new CNC router.
All right, we've made it to the NDSU Innovation Studio, and I'm here with Dave Savageau. He runs the facility. And so I want to just explain to people what is this place?
So we have 5 functional areas. We have a wood shop, a metal shop, digital fabrication, electronics, and sewing. And the special part about our lab is the proximity of all these areas. So it's being able to flow between all these areas seamlessly. We're here to serve all students and all community members. And so just come in, use all of these areas in conjunction with one another.
Is there age limits or?
The only age limit we have is we have to be 18 plus for insurance purposes.
Sure.
Other than that, we're trying to cater to entrepreneurs, product development, prototyping, that type of thing. Okay. We're not a production facility, we're a prototype shop.
Sure, and somebody's always here to facilitate
right.
the work. And
yep.
Okay.
Yep, so for right now, we're open 8 to 5 Monday through Friday. We just started taking memberships on in January, so we're planning for more full-time employees, more student helpers to expand hours.
Yeah, because a lot of the entrepreneurs who are coming up with these ideas are like 6 in the evening till 2 in the morning.
Yeah,
you know?
Yeah, and we get that, so we're trying to figure out a way to accommodate that.
Awesome. Well, this is amazing. So we're going to take a walk through the facility and just kind of show us the different areas before we get started on our project here.
Awesome. So the Research and Technology Park is really a center for entrepreneurs. We have the North Dakota Small Business Development Center. We have the Bank of North Dakota is here. We have all these resources to be able to help businesses start up and be successful. So this hallway that we're walking down right now, this used to be Bobcat's engineering offices. And they had cubicles going from the front of the building all the way to the back of the building.
Wow.
And so about 3 years ago, Bobcat moved out. We put this hallway in and broke this up into some smaller spaces. But Bobcat had a prototype lab. And so they had a perfectly good shop space inside of an office building, which is a really odd combination.
So I have a question about that.
Yeah.
You have office space here.
Yep.
If someone had a long-term prototyping project that they're trying to develop, could they rent an office space and do their prototyping back here, like set up their tool space as well? Or
Yep, absolutely. So if you need a business address, if you need a North Dakota business address, something like that, then for sure you can get an office space here. And our office spaces range from just a single office with a desk furnished all the way up to 25, 30 cubicles.
Wow. I didn't even realize that about this facility, that
Yep.
this is like a true entrepreneur's like diving board to jump into whatever they're trying to do.
Right. Yeah.
Wow.
Wood shop is, you know, a lot of the usual suspects of a wood shop. Table saws, band saws, chop saws, the basics, right?
Yeah.
And then something more advanced like the 4x8 CNC router. So I mentioned this was Bobcat's prototype lab, and this space used to be an indoor gravel pit. So up until a little over a year ago, this was a 4,200 square foot, 15-foot deep indoor gravel pit. Luckily, our board allowed us to concrete it and convert the greater part of one half to a metal shop, and then the lower area here to rentable project storage space, kind of some overflow. Yeah.
I don't see a lift for vehicles.
Not yet.
Okay, you thinking about setting that up?
It could be, yeah.
Okay.
Yep. Down the road, we're definitely thinking about a lift.
Okay. Awesome.
So Ben is testing out our CNC plasma cutter. That's a relatively new piece of equipment for us. So we have some welding equipment, fixture table, some metrology and machining equipment. You run the range of high tech and low tech.
Yeah.
All the tools are absolutely necessary to the process. It's funny, high tech, low tech, H-frame press, and then right next to it in that black case is a hexagon absolute scan arm.
Wow.
So there's we can touch probe and we can laser scan with that.
Yeah. So I'm envisioning, if you get the lift set up in here, or even without the lift, a person could pull their car in, they could scan if they wanted to make parts, for intake, turbos. They could do the scans. They can 3D print parts.
Yep.
In the other, we'll get over to that section soon, but
we'll get over to digital fabrication.
Man, this is amazing.
Yeah.
Well, let's keep moving through.
Yeah. Yep. So we've got 2 manual mills, 2 manual lathes. We've got a Haas TL1. We have a Haas mini mill. So we're getting people into machining.
Yep.
And something like this, all this machinery really is plausible for somebody to have in their garage.
Awesome. And what's so cool about this is that you don't have to be committed to 2 years or 4 years of school.
Right.
You can come in and kind of get your feet wet with different things that you might enjoy.
Yep.
And then maybe you want to pursue a career, right?
Yep. So we have a shear, mechanical shear, and a press brake. So this is a 6-foot, 70-ton press brake.
Wow.
So we can do almost 1/4 inch full length with this.
Wow. And how did you get this in here? Because that's massive.
Yeah, so our railings here are removable. They're in like pockets. So we
Gotcha.
can undo set screws and pull the railings off.
Yep.
And then we just forklift it right in through the door.
Oh, nice.
Yeah. It was interesting because they called me like 3 days before it was being delivered, and they said, "Hey, your stuff's coming. Figure it out." And so I had to quickly get a rigger. But
I hope it wasn't in January or something.
it was.
Oh no.
It was like -20 the day it got delivered.
Oh my
that
gosh.
morning, and the trailer actually froze shut. So we had to do some creative problem solving on that one. Wow. Back through here we have digital fabrication and electronics.
Okay.
So,
Awesome.
So digital fabrication covers 3D scanning, obviously 3D printing, vacuum forming, mold making, CAD. We have CAD computers in the back here. We have the laser cutters. Yeah. So these we have 10 of these Prusa Mark III S Pluses. It's a filament-based machine. Super easy to run, intuitive, cheap, low maintenance. Just no hassle. These are great machines. Next step up is probably these 2 Raise Pro 2 Pluses. We can do more temperature sensitive materials with the enclosure. Yeah, we're getting a Mark Forged Metal X. So we're printing metal in a similar form. It's metal powder in a wax binder that's on a spool. Neat. It prints really similar to these machines. And honestly, you can print that same material on these Prusas and stuff, but you have to send it off for post-processing. This machine, this is really awesome. It's pretty unassuming, but this is we're getting into engineering grade materials here. So we're putting continuous carbon fiber, in this case, between layers of plastic. So we're not printing carbon fiber, we're printing carbon into plastic.
And this is the textile studio.
Is textile sewing, whatever you want to call it.
Okay.
And you have a sewing space in your
Yeah,
shop. So
yeah, I do my interiors. I'm still learning a lot. Tell us a little bit like about the different machines you have. And
I think it's a running theme across all of our equipment is we try to get the highest level consumer before you get into industrial level equipment. Like a Janome M7 Continental, and because it is crazy high tech. So these are awesome machines. You can do your basic stitches, very complex patterns, some basic embroidery. So you go from these machines to the Conso 701, which is the total other end of the spectrum, high tech, low tech. Okay. And this machine doesn't even have reverse. So we can adjust stitch length on this, and that's about it. And then the post bed lets you get into maybe a shoe or a hat. I've sewn a leather patch onto a hat with this machine.
Oh, neat.
So just being able to feed it in there and get
work your way around it. Sure. That makes sense.
This is a quilting machine, so this is pretty unique. This is a Bernina Q24 quilt frame. So this is a freehand quilting head. So we're excited to see where people use these. So this is a Janome HD9. Most recently, this machine was used by a friend of mine who builds custom Air Jordan sneakers. And he had this complex area. It was several layers of leather, and he just needed to punch through them. So we use this machine for that. Yep. We have a serger. Right now, for training purposes, we have 4 different threads in here because if you look at this, you look at different sides of it, you can see where the different colors and what they're doing and adjusting thread tension and stuff like that. So that's purely for educational.
So is that a real hassle to change the thread out on that if you want a different color?
It's not too bad. This has an air thread option. So traditionally sergers are a real pain in the butt to change. This has a little air pump in it, so you get the thread close, you put it in a tube, and you push a little pump, and it pumps air through it.
That's cheating.
So this is a 7-color embroidery machine. This is an application where we actually did use all 7 colors on that.
Wow.
And
excellent.
Then this is a vinyl printer and cutter, so it just kind of makes sense to have down here, but we can just make custom stickers with this. And
well, man, this place has so much to offer.
Yeah.
I can see a lot of people getting a jump start into, whatever their dreams are. From here.
Yep, we hope so. We just want to be that connection point for, you have an idea, you want to make it. Let's help you work through it.
Yeah. Well, our big idea is building a wood buck.
Let's do it.
Yeah, let's go do it.
Yeah.
So we're going to be using the CNC router to cut this buck.
Yep.
This has been a long time coming.
Yeah.
So tell us about the machine a little bit.
Yeah, so this is a Multicam Apex 1R with a vacuum table and a 4-position tool changer.
Okay.
So for this project, we're going to be running a spindle at about 18,000 RPMs. We're using, it's called a compression bit. And being that this is all 2D cutting, we want to cut this in one pass, and we want a good finish on the top and the bottom. So this bit, you can see how it changes directions partially. So what we're getting with this, we're spinning clockwise all the time, but we're getting an up cut on the bottom and we're getting a down cut on the top.
Oh, wow.
And so it's pulling material in towards the center, and so you're not getting tear out like you would. You'll see it on sometimes traditional router bits or on saws. You'll get tear out on the backside. So we want to eliminate that, so we're using a compression bit.
Okay.
The table has 4 zones for the vacuum table.
Okay.
And so right now we're only using this area of the table. We can I can pop the hood on it and you can see how it works. So there's this grid that's in here, and there's holes, so the vacuum pump back there is sucking down through those holes, through the channels, and then we have gasket tape in there that breaks it off into quadrants. We're going to leave this on there. This is a spoil board. Okay. This is a material called LDF. We can also use MDF. It's just a low density, and so you can think of it like a sponge, and it's going to suck the material down to the LDF through the LDF. I like to call it like a reverse air hockey table. So it doesn't have a bunch of holes drilled in it, but it's going to do the same thing. Yeah. So if you want to hit that green switch there, so. And you'll notice the residual as the pump spools down.
Yeah.
It takes a little while.
Whoa.
Yeah.
That is so cool.
So we're sucking the material flat to the table. We're keeping it still. It also allows us to cut at a very precise depth and get right to the bottom of the material.
Without cutting into the LDF.
Yeah. So
Well, should we put a sheet of plywood on there and see what we can do?
let's do it. I'm telling the machine what bit to use, how fast to spin, conventional or climb milling. We're entering all these parameters in to ensure that it's cutting properly.
Gotcha.
And so for this, like I said, we're running at 18,000 RPMs. I think we're running at 130 inches a minute for our feed rate, and we're not doing multiple passes, we're doing one pass around the whole thing with that compression bit. So sometimes we might have a tool change in there where we switch over to this engraving bit, run your number in it for organizational purposes. It'll swap out, it'll grab that 3/8 compression, and then it'll do the cut, and then it's done.
And the bits are down there where it's grabbing.
Yeah. So there's a 4-position tool changer. So for this one, we're just running 2 tools. And so when we're ready to cut, we'll also turn our dust collector on, and dust collector vacuum table. So it's going to get a little loud, and then the spindle.
Okay.
So yeah, it's going to get a little loud. Yeah.
It's taken over 2 years from scanning the RS-010 buck to get to this point. If you've watched my other videos, you know I go back and forth on whether using modern technology is truly more efficient than the traditional methods I typically use for buck building. This is the first time I've seen the entire process through to the end. From the initial scans back in February of 2021, Rohit and I took the surface data and, as I mentioned, covered every square inch, refining, proportioning, and fitting to the chassis. We cut several scale models of the file to get a hands-on view, which helped me immensely to get a feel for the overall shape. With the files nearing completion in April of this year, we did one final check against every data point from the running gear. We found that several areas were off and needed to be reproportioned. I can't thank Rohit enough for going the extra mile. Seeing the buck come to life through the CNC router process was incredible. Here are a couple of things we learned during the CNC process that might help viewers out. A common question when doing the interlocking sections is how do you get the interlocking corners routed so that the pieces will fit flush? In our case, we compensated on the surface of the buck for this factor. In the end, I'll hand plane the surface down at my shop for the fine tuning of the overall shape. We also found that with the plywood thickness being 703 thousandths, we could have made the slots a bit larger. We cut them at exactly 703, hoping it would make for a perfect fit. But with the humidity, the plywood pieces had swollen and it was quite difficult to slide the pieces into place. I would suggest cutting a few test pieces with the product you're using and checking your interlocking pieces prior to doing the full project. We could have cut an hour or so off our assembly time in this area. All right, so we've got the buck pretty much done. As you can see, the majority of the work is here. We don't have the hood, the rear deck lid, and the doors with us today. We didn't have the files quite yet, but this was, I think, a great first try. This is the first time you guys have ran this machine.
Yeah, the pieces we've done up until this point have just been samples for this project.
Awesome. So this project is 3/4 inch plywood, and I think the machine handled it really well. What do you think was the hardest part of the process today?
Other than putting it together, I think I can't really identify any one thing. The machine performed flawlessly. Yeah. Maybe we had one sheet of plywood that warped a little bit.
Yeah, so it was hard to suck it down to the table.
Yeah, and it was a compound warp, so it was warped over the length and the width. So that little bit kind of caused some issues, but it's plywood, we got to deal with it.
Yeah, we had a few extra pieces with us, so we were safe on that one. Yeah, now we can get back to the shop, unload this thing, and start shaping some metal.
Yeah.
Thank you, Dave, so much.
Of course.
Yeah, and we're going to put a link to the NDSU Innovation Studio in the description of this video, so you guys check that out. If you're anywhere in the Midwest, I mean, whether you went to NDSU as a student or you want to prototype something, I mean, from small stuff to big projects, people could come here and really get a jump start on their dream, right?
Right, yeah, come in with a file, leave with a car buck.
Yeah, all right.
Okay.
So check out our other videos. You guys subscribe, comment, ask questions. Maybe we can get Dave to pipe in on the comments and help answer questions if you want to.
Yep.
Yeah.
I'll pay attention to it.
Awesome.
All right.
Yeah. See you guys on the next video.
See ya.
That was awesome.